Hello everyone. In this video, I will go over a few questions involving factoring. Before I get started with this question, I would like to remind everyone a formula is called the difference of square. So once you have a difference of square, it means that you have a square and then another square and then you subtract them. So the last operation between these two operations is the subtraction. It's called the difference of square. The special formula for that will be a minus b multiplied with a plus b. So these are the factors of this expression a squared minus b squared. So this is a formula that we should remember. So if you multiply this out, you expand these two factors, you should end it up with the original expression, a squared minus b squared. So this is a special formula called the difference of square. Alright, so make a note of this, the difference of square. Alright, so let's move on to the question itself. Okay, so in this one, I have the difference of square. But the 25 and the 4, I need to turn that into a perfect square. B to the exponent 4 can be written as a perfect square also. So what I'm going to do is I will write it like this. Okay, I will write 25 as 5 square. A square, I leave it as square. I will write b square, all of it to the exponent 2, because I raise a power to an exponent, I multiply the two exponents. So b to the exponent 4 can break into a perfect square of b square, all of it in a bracket square. So I do the same thing for 4. I will do 2 square c square. So there are a few formulas involving exponent that we need to remember. So the first formula is this one. Okay, if you raise a power to an exponent, what you do is you multiply the two exponents. So I apply that for b to the exponent 4. Okay, so the next formulas I am going to remind everyone is if you have a raised to exponent n, also b raised to exponent n, then you can write the expression as a plus b as the same base and all raised to the exponent n. So I can write 5a squared b squared all of it to the exponent 2 as a times 5 times b squared all of it to the exponent 2 subtract 2c all of it to the exponent 2. So I need to have all of these as the exponent 2 before I can apply the formulas of the difference of square. So a squared minus b squared will be a minus b, a plus b as the given formulas. Alright, okay, so there are a few concepts that we need to remember. We need to remember the exponent. We also need to remember these formulas. We apply this to this difference of square factors in its factoring form. Okay, so now from here, I can put 5ab squared minus 2c, all of it in the bracket, and then I multiply that with 5ab squared plus 2c in the brackets as is factors. Alright, so how do we know that we done this correctly? Okay, so what I'm going to do is I'm going to expand them and to prove that in the end I am having the same expression to begin with. So these are the expression here. And then I break them into these two factors. And how do I know that I got it right? Okay, so to get it right, I'm going to expand them and check if I have the correct answer. So I'm doing this just to remind everyone about the formulas that I've shown everyone earlier. So this one right here, the difference of square. Okay, this is the special formula. Its factor will be a minus b, a plus b. And after you expanded this, you should get back to its original expression, which is a squared minus b squared. It's a very important formula in algebra, and we need to master this concept. So if I multiply them back in, what do I get here? Okay, 5ab squared times 5ab squared, I should have 25a squared b to the exponent 4. And then I should have 5ab squared times 2c, I should have plus 10ab squared c. Okay, and then I take negative 2c, I multiply by this, I should have negative 10ab squared c, and then 2c multiply positive 2c multiplied with negative 2c, I should have negative 4c squared. So if I collect the like term, you see this and this cancel out, and my final answer should be 25a squared b to the exponent 4 subtract 4c squared. So I get back to my original expression of 25a squared b to the exponent 4 minus 4c squared. Alright, so this involving the difference of square. Okay, so keep that in mind. Alright, so let's move on to the next question. So the next question I have here is also the difference of square, right? It is somehow the difference of square. So I have negative here as subtract x squared, y squared, but 18 is not a perfect square. 50 is also not a perfect square. So I may have to think of a common factor in this case. So if I take a common factor of 18 and 50, the perfect square may reveal itself. Okay, so think about that analysis. So if you don't have a perfect square as a variable or coefficient for the x squared, you may have to think of doing a common factor. Okay, so 18 and 50, the common factor is 2. So if I take out the common factor of 2, then I should have 9x squared subtract 25y squared inside the brackets. So after I've got this, I see that 9 is a perfect square, which is 3 square. 25 is perfect square, which is 5 square. So I can write it as 2, 3 square x squared, 5 square y square. Alright, and then I apply the formulas that I've shown everyone earlier. Okay, so if you have two different bases, but they both raise to the same exponent, you can combine them to make just one exponent. So in this case, I will write it as 3x, all of it square, subtract 5y, all of it square. So now I can apply the formulas of the difference of square. A squared minus b squared should be equal to a minus b, multiply a plus b as its factor. So then I will write 2, then I will write 3x minus 5y, multiply that with 3x plus 5y as my final answer. So for this question, I am not going to multiply them back in to check if I have the final solutions right here, 18x squared minus 50y squared. You can do that if you can, but we know that we should have a correct answer. Okay, so I did that for question number 1, just to show everyone that sometimes you can try to perform that step yourself to make sure that you've done it right. All right, so I'm going to move on to another questions. All right, so this one, we was asked to factor this. Then we go back to the formula to see what I list up here. So what I list up here is the difference of square, the special product, and the sums and difference of cube. But what we have here is the trinomials. Okay, so there are a few ways to factor these trinomials. You can treat it as a quadratic equations, and then you can solve the unknown, and then you have to apply some the application of excuse me. I'm sorry, I paused right there because I just want to take a sip of tea. So let me repeat what I just tried to say. So you can treat it as a quadratic equation. Ax squared plus bx plus c equal to 0. And you assume the sign equal to 0. You solve for x. And then you apply the concept of if you have the solution for quadratic equation, then you can do something with that solution to make it reveal the factors of these trinomials. Okay, so that's one method. But one method that I'm going to show everyone is that you need to find two numbers, okay? And before you find that two number, you take a look at this number 54 and the number negative 40. So in a way that I referred it to ax squared plus bx plus c. Okay, so this is in terms of like a quadratic forms. Sorry, I just need to write this properly. Quadratic. Quadratics means that you have the x squared as your highest exponent for your variable. Then it comes to x to the exponent 1. And then right here, it should be x to the exponent 0. Okay, so don't forget, anything raised to exponent 0 is equal to 1. So x raised to exponent 0 can turn into 1. That's why I just write it as c. So a quadratic equation, that means you set it equal to 0. But this is in terms of the quadratic as a trinomial. You are having x squared, then you have x to the exponent 1, then you have x to the power of 0. Okay, so if you have your expression, the trinomial, in this form, then in order to factor these trinomials, you need to follow the following rules. All right, so you are going to take a times c equal to a number. Okay, so I'm going to put a question mark here. And then from this, you are going to look for two numbers that multiply. So I'm looking for x1 and x2. And if I multiply x1 and x2, I should get this product. Okay. And then, but that same two number, x1 plus x2, have to give me the middle variable. So it should give me this variable b here. Okay. So keep this in mind, okay? You apply this method when you have an expression in terms of quadratics. So quadratic is a trinomial, so three terms. The first term consists of x squared. The second term consists of the a coefficient with x to the power of 1. The last is just a number. However, this number should represent it as c times x to the exponent 0. Okay, so take the variable a times the coefficient a times the coefficient c. Okay, a is the coefficient in front of x squared, c is the coefficient in front of x to the power of 0. So if you have this product, then you need to find two numbers that multiply themselves to give you this product, the same two numbers adding to give you b. So let's follow that. Okay. What I'm going to do is I will do another video. Okay, I will make a note to remind myself here to do another video involving the solving for quadratics. Using quadratic formulas, and then from the quadratic formulas, you can pull out your factors. Okay, so using quadratic, solving for quadratic equation, assuming that I let this expression equal to 0. So I will make a note here that I will do another video like this, because sometimes when you take c times a, you have a very large number to work with, and the process may be tedious for you to figure out the other two numbers. Multiply will give you this product, and the same two numbers will have to give you the middle coefficient of the x to the exponent 1. Okay, so which is b. This can be tedious. Therefore, some students just want to follow the formulas, using the quadratic formulas to figure out the two unknown, okay, of this, assuming it is an equation, solving the two unknown, and then they substitute it into a formulas to figure out the two factors of these trinomials. But I will get to that after this video. And so let's get started here. So what I have to do next is I will take 54. I time that with negative 40. Don't forget to involve the negative sign as well. All right, okay. So when I multiply these two numbers, I should end up with negative 2,160. Okay, so let's check that. Yeah, negative 2,160. So now negative, I need to find two numbers that multiply and give me this negative 2,140. So that two numbers that I actually found is 48 and negative 45. Okay, so 48 multiplied with negative 45 will give me this number. And to get positive 3 as the coefficient for x, the middle terms here, then if I take 48 subtract 45, I get to that number 3. So these are the steps. Okay, so after you found these two numbers, 48 and 45, negative 45, what do you do? So what you do in this case is you are going to break the middle term into 48x and negative 45x. So you write your statement as 54x squared plus 48x minus 45x subtract 40. Okay, so this two middle term add up to be 3x. Okay, so what you do next is you have to factor by grouping. So you group these two terms. You find a common factor for this two terms. The first two terms, my common factor should be 6x. Here I should have 9x plus 8. Okay, so check 6x times 9x is 54x squared. 6x times 8 is 48x. The next common factor I can pull out is negative 5. So then I should have 9x plus 8 inside the bracket. Negative 5 times 9x is negative 45. Negative 5 times plus 8 will give me negative 40. So now you see that this and this are your common factor. So you take this out as your common factor. What you have left inside the bracket should be 6x minus 5. So these two factors are the factors of the trinomials that given to us at the beginning here, 54x squared plus 3x minus 40. Okay, so if you want to check your answer, you can always multiply the mouse and then see if you have the correct answer. Okay, so this will give me 54x squared minus 45x plus 48x minus 40. Combine the two terms here, I should have 3x minus 40, which is equal to the original expression that they asked us to factor. Alright, okay, so let's move on to the next question. Oh, so this question here is a bit complicated, okay? It's the difference of square hidden between these two terms. Is the difference of square hidden between these two terms. So what I'm going to ask you to do is just to follow the method that I show you next, involving the deep understanding of exponent. Alright, so again, the deep understanding of exponent is this. am raised to exponent n will be am times n. Alright, and if you have the same base raised to the exponent, you can break them into the two base raised to the same exponent. So what I'm going to ask you to do is think of 16 as 4 square. Okay, 9, think of it at 3 square. And then x minus 1, all of it in the bracket square. Alright, so you see 16 is 4 square. 3 square will give you 9. The negative sign remains here, right? So x minus 1, all of it square, just stay the way it is. Because sometimes the student will immediately expand this and try to factor this. In the end, you still can get the same answer. However, the method will be quite tedious. So I will follow my the concept of these two statements, and I will rewrite it as, and all of it raised to the exponent 2. So if you see that, 3 raised to exponent 2, x minus 1, all of it in the bracket, raised to exponent 2. This will reveal the formula a squared minus b squared equal to a minus b, a plus b. And what is a in this case? A equal to 4. And what is b equal to? B equal to 3 times x minus 1. Okay, so then I will write it as 4 minus 3 x minus 1. This whole thing multiplied by 4 plus 3 times x minus 1, close the bracket. So because I have to factor completely, I need to expand this, and then I will collect the like term. So we'll have 4 subtract 3x plus 3, 4 plus 3x minus 3. Then I should have 4 plus 3 will give me 7. So 7 minus 3x. And for the second term, I should have 1 plus 3x. Okay, so these are the common factors. I mean, not the common factors. These are the factors of the expression hidden as the difference of square. Alright. Double check. Okay, so let's move on to the next question. This question right here is the difference of cube. So let's go back to see the formula that we have to work with. So here is the formulas for the difference of cube. Okay, difference of cube, a cube minus b cube, its factor will be like this. Okay, so let's go back to this question. I have 27 in front of the x cube. I need to change this into a perfect cube. So it will be my 3 cube x cube. 8, I turn it into 2q y cube. I also write it as 3x, all of it to the exponent 3, minus 2y, all of it to the exponent 3. Again, I follow the formulas, the exponent formula that I showing everyone earlier. Okay, so now the perfect cube review itself. So the formulas for the cube is, as their difference is like this. Okay, so let's substitute these into the formulas. So I will have 3x subtract 2y, multiply this with a squared. Don't forget to square the entire 3x, plus 3x multiply that with 2y, and I should have plus 2y all of it square. So the final statement should be this. So in here, I should have 9x squared plus 6xy plus 4y squared. Alright, so this is the final answer for the difference of square 27x cubed minus 8y cubed. Alright, so let's move on to the last question. Alright, so this one is a sum of cube. However, 3 is not a perfect cube, 24 is not a perfect cube. So what you want to do is like apply the previous concept. I mentioned this in previous question, that you should try a common factor. Okay, so common factor between 3 and 24 is 3. So if I write 3, here I should have 8. And then you see 8 is a perfect cube. So I can change this into, so 3, I better rewrite to make sure that. So it's 2q y cube, right? Okay, so I'm going to rewrite this as 2y, all of it to the exponent 3. Then the formulas for the sum of cube is a cube plus b cube will be equal to a plus b multiplied by a squared subtract a times b plus b squared. Alright, okay, so this is the formulas. Special formula applied to the sum of cube. So right here, here's the formulas for the sum of cube. And we already figure out the what a equal to and what b equal to. So this should be my a, and this should be my b. So it will be 3. Multiply that with x plus 2y. Okay, and for this I should remember that is x squared subtract 2 times x times y. Okay, so a times b is, a is x, b is 2y. So when I have x times 2y, I can write it as 2xy. And the b squared, be careful, I should add that with 2y, all of it square, involving b as both the 2 and the y. So the final answer for this one should be x squared minus 2xy plus 4y squared as the final answer. Okay, so I reached my almost reached my 30 minutes max here. So thank you everyone.